Hello and welcome to today's episode, which deals with the meaning of hardware and software of the computer system. This episode will also explain the architecture of the computer system. I'm Amrita Ghosh and the subject expert is Dr. Nazia Hussain, teaching in Bangalore University. Today, we will take a broad overview of the concept of the architecture of a computer system. Computer is potentially a very powerful data processing tool. It consists of the units known as peripherals, devices. It serves either a means of feeding data into the system or receiving results from the system. Someone who processes things is a processor. It is the part of a computer that does most of the data processing. The central processing unit and the memory form the central part of a computer to which the peripherals are attached. The above figure is a block diagram for a generic computer system. This figure shows that a computer consists of a central processing unit, the CPU, a clock, memory, and peripheral or input-output devices. All of these subsystems communicate over a CPU bus. The processor subsystem of data processing system processes received information after it has been encoded into data by the input subsystem. These data are then processed by the processing subsystem before being sent to the output subsystem where they are decoded back into information. The part of a computer that does most of the data processing, the CPU and the memory, form the central part of a computer to which the peripherals are attached. The central processing unit is the part of a computer that interprets and carries out the instructions contained in the software. Since a computer follows input-output process cycle, the first stage is performed in computer by input unit. The second stage is performed by its central processing unit and the third stage is performed by its output unit. The input unit provides an interface between the users and the machine for inputting data and instructions, etc. One of the most common examples is the keyboard. Data can be put in many forms: audio, visual, graphical. Some common input devices are listed below: the keyboard, the mouse, the voice data entry, the joystick, the scanner. Secondary storage devices such as floppy disks, magnetic tapes, etc. The input unit is responsible for taking inputs and converting it into a computer understandable form, that is the binary code. Since a computer operates on electricity, it can only understand the language of electricity, that is either on or off, or high voltage or low voltage. The data in any form is first digitized, that is converted into binary form by the input devices before being fed to the central processing unit. Functions of the input unit. 1. It provides a means for the machine to communicate with its external environment by accepting data and the list of instructions. Number 2, it converts these instructions and data in computer acceptable form. Number 3, it supplies the converted instructions and data to the computer system for further processing. Pointing devices, which are input devices, can be further classified into following. 1. Touchscreen and light pens, which include direct input. Number 2. Mouse and trackball, which involves indirect input. The CPU is the control center for a computer. It guides, directs, and governs its performance. It is the brain of the computer. The CPU, or the central processing unit, otherwise known as the processor, is an electronic circuit that can execute computer programs. The input and output devices may vary for different applications, but there is only one CPU for a particular computer. The specifications of a computer are basically characterized by its central processing unit. The central processing unit, or the CPU, is the hardware within a computer system, which involves the instructions of a computer program by performing the basic arithmetical, logical and input or output operations of the system. The CPU processes the data it receives as input either through input devices or through the memory. CPU performs many tasks, some of which are listed below. The CPU performs arithmetic calculations such as additions, subtractions, multiplications, and so on. The CPU can perform logical decisions. The CPU, with the help of other devices, can perform data transmission. The CPU can perform manipulating tasks such as word processing. After performing the required tasks, the CPU may place results in the memory or send the results to the output device according to the instructions given to it. The CPU, with the help of its control unit, generates timing signals, also known as enable signals, which provide synchronization between the different devices and the CPU. The CPU has two components. The ALU is a fundamental building block of a CPU of a computer. The ALU performs all the four arithmetical operations like addition, subtraction, multiplication, division. Logical calculations are basically decision-making statements. For example, A is greater than B decides whether A is greater than B or not. If A is greater than B, the statement is true and logical. 1 would be generated. Otherwise, a logical 0 would be generated. When two numbers are required to be added, these numbers are sent from the memory to the ALU, where addition takes place and the result is put back in the memory. The same way other arithmetic operations are performed. For logical operations also, the numbers to be compared are sent from the memory to the ALU, where comparisons takes place and the result is turned to the memory. The result of logical operations is either true or false. These operations provide the capability of decision making to the computer. An ALU is the part of a processor that carries out arithmetic and logic operations on the operands in computer instruction words. In some processors, the arithmetic logic unit is divided into two units, the arithmetic unit and the logic unit. The other important element of the CPU is the control unit, which is required to supervise the functioning as a whole. The control unit controls the entire operations of the computer and the CPU. It controls all the other devices connected to the CPU, that is input devices, output devices, auxiliary memory, etc. Hence, the control unit acts as the nerve center of the computer. The control unit, upon receiving an instruction, decides what is to be done with it. That is, whether it is to be sent to the ALU for further processing or to the output device or to the memory, etc. In other words, the control unit coordinates and controls all hardware operations. Control unit refers to a functioning unit which carries out four basic operations. 1. Fetches an instruction. 2. Decodes the instructions. 3. Executes the instructions. 4. It stores the result. The control unit even controls the flow of data from the input devices to the memory and from the memory to the output devices. The output unit is performed by the output devices attached to the computer. The output unit also provides an interface between the user and the machine. A common example is the visual display unit or the monitor of a personal computer. The output unit receives the data from the CPU in the form of binary bits. This is then converted into a desired form understood by the user. Some common output devices are the visual display unit or the monitor, the printers, the speakers, the secondary storage devices, the plotter, etc. The input and output units collectively are referred to as the peripherals. In other words, an output device is any piece of computer system, hardware equipment used to communicate the results of data processing carried out by an information processing system to the users. In computing, input or output refers to the communication between the computer system and the user. Inputs are the signals or data sent to the system, and outputs are the signals or data sent by the system to the outside. The memory of a computer is often called the main memory or primary memory. It is generally the third component of CPU. The memory of the computer is most unlike human memory. A human being can remember stored information for a long time, whereas a computer cannot. Its memory is temporary, that is volatile. It cannot remember anything after it is switched off. In other words, memory means physical devices that are used to store programs or data on a temporary or permanent basis for use in a computer system or other electronic device. The memory of a computer is more like a predefined working place where it temporarily keeps information and data to facilitate its performance. When the task is performed, it clears its memory and memory space is then available for the next task to be performed. When the power is switched off, everything stored in the memory gets erased and cannot be recalled. The memory cell may be defined as a device which can store a symbol selected from a set of symbols. Each of its cells is further broken down into smaller parts known as bits. A bit means a binary digit, that is either 0 or 1. A number of bits together are used to store data instructions by their combinations. A bit is an elementary unit of the memory. A group of 8 bits is called byte and a group of 4 bits is called a nibble. 1 byte is the smallest unit which can represent a data item or a character. Other units of memory are the kilobyte, the megabyte and the gigabyte. 1 KB or kilobyte means 1024 bytes. 1 MB or megabyte means 1024 into 1024 bytes. 1 gigabyte or GB means 1024 into 1024 into 1024 bytes. Since computers' main memory is temporary, secondary memory space is needed to store data and information permanently for later use. The two most common secondary storage media are the floppy disks and the hard disk. The computer makes use of two types of memories, one internal memory, two external memory. The internal memory is the built-in memory where CPU holds the programs and data being manipulated. There are two types of internal memory. In this memory, information once stored remains fixed, that is, it cannot be changed. So, ROM can only be read and used, it cannot be changed. Generally, ROM contains a set of startup instructions. That is what to do when a computer is turned on. The contents of ROM remain stored even if the power is turned off. Types of ROM. Other types of non-volatile memory are 1. Programmable read-only memory. A PROM. A PROM program is used to record information in the PROM chip. Information once programmed into the PROM chip is permanent and cannot be changed or erased. The process of entering the information into the PROM chip is known as burning the PROM. PROM chips are seldom used in modern-day computers, but they still find their use in devices where a permanent ROM is required. Masked read-only memory, the MROM. In the MROM, the information is permanently recorded by the masking and metallization process. It is not easy to perform this process as a large infrastructure is required, and therefore it is usually the manufacturers who perform this process. Erasable programmable read-only memory, or the EPROM. An EPROM is an erasable PROM. An EPROM can be reprogrammed using an EPROM programmer. Exposing it to high-intensity ultraviolet light for 30 minutes can erase the contents of an EPROM chip. An ultraviolet source with a wavelength of 2537 A is used for this purpose. The process of changing the content is not convenient as the chip has to be removed from the board of exposure to the ultraviolet light source. Another disadvantage is that the user cannot erase the contents of a single memory location and the entire memory contents have to be erased. The EPROM chip is cheap, reliable and widely available. The electrically erasable programmable read-only memory, or the EPROM, using electrical signals can alter the information, and that is why the chip need not be removed from the board. One major advantage that this chip has over the EPROM is that even single memory can be altered. That is, the entire memory need not be erased by reprogrammed unless required. The change in the contents of the EPROM chip is made in milliseconds, which is much less than the erasing time for EPROM. The internal memory that can be read from as well as written to is called RAM, that is random access memory. When people talk about the computer memory in connection with the computer, they usually mean the RAM. The random access memory is volatile, that is, its contents are lost when power is turned off. Because of RAM's following limitations, auxiliary memory is needed. There are two different types of RAM. Dynamic RAM or the DRAM. The dynamic RAM chip contains a transistor that acts as a gate to a capacitor which is capable of storing electrical charges. The charge on the capacitor indicates a 1 bit and no charge indicates a 0 bit. The charge on the capacitor leaks away after a few milliseconds. Therefore, a dynamic RAM has to be refreshed periodically after every 2 milliseconds. A DRAM uses its contents in a very short time even though the power supply is on. A DRAM consumes less power and has higher packing density. It is cheaper than the static RAM. The static RAM. The static RAM are also volatile in nature, but they need no regeneration to retain the data. They retain the data as long as they receive the power. The static random access memory consumes more power and is more expensive. The static RAM chips are more complicated and hence require more space. Static RAMs are faster than the dynamic RAMs. Static RAMs are recommended for medium-sized memories while dynamic RAMs are recommended for large-sized memories. Computer random access memory is the best known form of memory your computer uses. Every file or application opened is placed in the RAM. Any information the computer needs or uses becomes part of a continuous cycle where the CPU requests data from RAM, processes it, and then writes a new data back to the RAM. This can happen millions of times a second. However, this is usually just for temporary file storage. So unless the data is saved somewhere, it is deleted when the files or applications are closed. Limitations of RAM. 1. Limited storage capacity. 2. Volatile in nature. That is, its contents get removed when power is turned off. The external memory is used to store temporary information permanently or semi-permanently. The most common external storage devices are hard drives, floppy disks, magnetic tapes, CD-ROMs, video disks, etc. A hard drive is a form of computer memory that allows you to permanently store data. This is where all of your permanent files and programs are stored. On computers running with Microsoft Windows, the hard drive is often called the C drive. The size of a hard drive is typically measured in gigabytes. A floppy disk is a disk storage medium composed of a disk of thin and flexible magnetic storage medium, sealed in a rectangular plastic carrier lined with fabric that removes dust particles. They are read and written by a floppy disk drive, FDD. Floppy disks initially as 8-inch or 200mm media and later in 5.25-inch or 133mm and 3.5-inch, that is 89mm sizes. Magnetic tapes is a medium for magnetic recording made of a thin magnetizable coating on a long narrow strip of plastic. Devices that record and play back audio and video using magnetic tape are tape recorders and videotape recorders. A device that stores computer data on magnetic tape is a tape drive. CD-ROM is the most popular type of drive after hard drives and floppy drives. Compact discs are optical storage devices similar to audio CDs and can store approximately 640 MB. In personal computers, we generally use CD-ROM. The information on CD-ROM cannot be changed. Since new writable CDs have come into the market, it has become very convenient to store large amounts of data, making it easy to transport. Video disk is a general term for a laser or stylus readable random access disk that contains both audio and analog video signals recorded in an analog form. Data communication equipment or DCE refers to computer hardware devices used to establish, maintain and terminate communication network sessions between a data source and its destination. DCE is connected to the data terminal equipment DTE and data transmission circuit DTC to convert transmission signals. Data communications equipment DCE are referred as equipment that sends or receives analog or digital signals through a network. DCE works at the physical layer of the OSI model, taking data generated by data terminal equipment and converting it into a signal that can then be transmitted over a communications link. A typical example of DCE is a modem which works as a translator of digital and analog signals. DCE is responsible for providing timing over a serial link. In a complex network, it uses directly connected routers to provide serial links. One serial interface of each connection must be configured with a clock rate to provide synchronization. Other common DCE examples include ISDN adapters, satellites including base stations, microwave stations, NIC or the network interface cards. DCE is sometimes also called the data circuit terminating equipment. Let us quickly summarize what we have learned today. Computer is potentially a very powerful data processing tool consisting of the units known as peripherals devices, which serve either a means of feeding data into the system or receiving results from the system. Since a computer follows input-output process cycle, the first stage is performed in computer by input unit. The second stage is performed by its central processing unit, and the third stage is performed by its output unit. The input unit provides an interface between the user and the machine for inputting data and instructions. One of the most common examples here is the keyboard. The central processing unit, or the CPU, is the hardware within a computer system which involves the instructions of a computer program by performing the basic arithmetical, logical, and input or output operations of the system. The CPU processes the data it receives as input either through input devices or through its memory. The output unit is performed by the output devices attached to the computer. The output unit also provides an interface between the user and the machine. A common example is the visual display unit or the monitor of a personal computer. The output unit receives the data from the CPU in the form of binary bits. This is then converted into a desired form understandable by the user. Memory refers to the physical devices used to store programs or sequences of instructions or data on a temporary or permanent basis for use in a computer or other digital electronic devices. Data communications equipment, or DCE, refers to computer hardware devices used to establish, maintain and terminate communication network sessions between a data source and its destination. DCE is connected to the data terminal equipment DTE and data transmission circuit DTC to convert transmission signals. That is all for today. Hope you have understood the concept of architecture of computer system. We'll see you again with another topic on the information technology subject. Till then, take care and bye.